Alright, we've left the borders of the solar system, and now I'm sitting in my spaceship cabin watching comets and asteroids pass by. Time to think about my destination. In the center of pretty much every galaxy, there's a supermassive black hole. For example, one is sitting right at the heart of our Milky Way galaxy, about 27,000 light-years away from Earth. But even my ship wouldn't be able to get that far before my 100th birthday. That's why my destination is the stellar black hole nearest to Earth and much smaller in size, but no less mysterious. It's V616 Monocerotis, also known as V616 Mon, located 3,000 light-years away and weighing the same as about 9 to 13 of our suns. A black hole is an eerie place where those laws of physics we studied at school stop working. If a massive star runs out of its star fuel, it becomes super dense and buckles under its own weight, collapsing inward and bringing space-time along. As a result, the gravitational field of this new thing gets so strong that nothing can escape it, not even light. Right now, we're approaching the black hole, and very soon I'll send Liam to explore it from the inside. I won't go further than the horizon, also known as the point of no return. And you can probably guess why, right? Once an object crosses this invisible line, it can't turn back, even if it changed its mind. Anyway, Liam says he's ready to start his journey. There he goes, bravely plunging toward the black hole while I'm recording everything that's happening to him. He's accelerating. It looks like he's contorting and stretching, as if I'm looking through a huge magnifying glass. Interestingly, the closer to the horizon he is, the more slowly he seems to move. He's trying to send me encoded light messages like we agreed to in advance, but the light waves stretch to redder and lower frequencies. I'm okay. I'm okay. What's happening? Liam just froze, as if a gigantic finger has pressed a pause button, and now some force is stretching him thinner and thinner. I've read about this phenomenon. It's the infamous spaghettification, which happens in a super strong non-homogeneous gravitational field. The black hole's gravity force is stronger at his feet than at his head. That's why he's getting stretched out like a piece of spaghetti. Also, the sensors inform me that Liam is getting hotter and hotter, and then nothing. He just disappeared, and I can't see him anymore. But since I did my research before the trip, I know that Liam is in the state of free fall now, and feels no more stretching, scalding radiation, or gravity. Unfortunately, the connection is lost, and he can't tell me anything about the inside of the black hole. This is a moment I didn't think through well enough. Anyway, I hope you're okay out there, my friend, and I think I'll head home to get ready for my next space trip.
You wake up, and a sharp smell of rotten eggs hits your nostrils. You look around wildly and realize the smell isn't coming from your mom's cooking downstairs. It's super hot, and there are giant red clouds churning in the sky. Yikes! You're on Venus! The planet is named after the ancient Roman deity of beauty and love, but sadly, its smell doesn't correspond with its name. The atmosphere of Venus is made up mainly of carbon dioxide, but thick clouds of sulfuric acid completely hide its surface from prying eyes. Sulfur has a really bad stench, which causes the surface of Venus to smell like rotten eggs. Gross! The atmosphere on the planet is also really hot and thick. The carbon dioxide traps a small amount of energy from the sun that reaches the planet's surface. This greenhouse effect has made Venus one of the hottest places in the solar system. So, the good news is, you wouldn't be able to smell the planet's stench, as humans can't survive on its surface. Well, that's a relief. Almost all other planets in our solar system only have a super small selection of different scents on their surface, unlike Earth. But what about our moon? The scent of the moon is similar to something called smokeless powder, which is a propellant used in firearms. Basically, the dust on the satellite smells exactly the same as when a shot is fired. Apollo 17's pilot Eugene Cernan says he could smell it straight after removing his suit from the spacecraft. But nobody's exactly sure why it smells like this, as there's zero similarity between the two substances. Smokeless powder is made up of a mixture of two things with very complicated names: nitroglycerin and nitrocellulose. Black powder, its older counterpart, is made of charcoal, saltpeter, and sulfur, which makes it smell in a very specific way, but not like rotten eggs, despite the sulfur content. Moon dust is made up of a bunch of things that primarily come from broken meteorites. This includes iron, magnesium, and calcium, but it doesn't contain either of the things in smokeless powder, or black powder either for that matter. And what's weirder is that moon dust samples brought back to Earth have been odorless. Experts say the smell could have been the dust reacting with oxygen or water inside the lander. The smell could also be due to the temporary release of charged particles from the sun that had become trapped in the dust. Mercury is the planet closest to the sun, but it doesn't really have a strong smell. This is because the atmosphere is so thin and scattered. Mars. Like Venus, it's another world that doesn't have the best scent ever. It's a good thing we can't breathe its air. The red planet smells like rotten eggs, again caused by sulfur. If human colonies did move to Mars, it looks like we'd have to burn a lot of scented candles to cover the smell. But the good news is that the sulfur quantities are pretty small, so the smell wouldn't be too overwhelming. Jupiter also has a whiff of eggs, but also smells a bit like it's been mixed with cleaning products. This is because its atmosphere is a mixture of hydrogen sulfide and ammonia. But what you smell basically depends on where you are in the planet's atmosphere. Some regions have higher concentrations of ammonia. This substance is used in a bunch of cleaning products here on Earth. So areas high in ammonia could have that strong burning stench of cleaning fluid. A lot of people also say that ammonia smells like a pair of dirty socks that haven't been washed in forever, so it's for sure best to avoid these parts of the planet. Other areas have a lot of hydrogen sulfide, and because it contains sulfur, these parts would also smell like rotten eggs. The third and final scent you'd find on Jupiter is bitter almonds, or marzipan, just like the kind your grandma puts on cakes around the holidays. This is in areas where a substance called hydrogen cyanide is most common. Jupiter is the biggest planet in our solar system. It's so big that it's 2.5 times larger than all of the other planets in the solar system combined. It's also the fastest spinning planet in our solar system. Next up, the ringed planet, Saturn. Its atmosphere is made up of about 96% hydrogen and 4% helium. Yes, that's the gas that makes your voice go all squeaky. Both hydrogen and helium are odorless, so Saturn probably doesn't have a strong smell. It does, however, contain traces of our good friend ammonia. That's the smelly sock gas. Saturn's atmosphere also has a bit of phosphine, which can sometimes smell like garlic or decaying fish. So there might be a slight bad stench in the air. The thickness of Saturn's atmosphere is only 37 miles. For comparison, our atmosphere here on Earth is almost 300 miles thick. Saturn also has some of the strongest winds in our solar system. They can reach a whopping 1,118 miles per hour. One of Saturn's moons is called Titan, and it has a super odd scent. Its atmosphere is made up of something called benzene, which has really weird effects if inhaled by us humans. It can make us feel dizzy and make our ears ring. It doesn't actually smell that bad though. Its scent is kind of like almonds. Now it's time to take a dive into Uranus. This gas giant has gotten itself a reputation as the smelliest planet in the entire solar system. There's a lot of stinky stuff floating around on the planet, and its upper atmosphere is made up mostly of hydrogen sulfide. Yep, that's the molecule that makes rotten eggs smell so nasty. But the temperatures are so severe on Uranus that you'd pass away even before you've had a chance to smell anything. Uranus's atmosphere is a staggering negative 392 degrees Fahrenheit. That's so cold that it would almost instantly freeze anyone.
Thousands of strange spaceships sneak into Earth's airspace. They descend to our planet and fly through cities, plunging people into complete chaos. Suddenly, the door of the largest ship opens, and a strange creature comes out. It tries to copy our language and says they had come from a distant star, Proxima Centauri. Something like this might happen because scientists have recently picked up a strange radio signal off that star. Proxima Centauri is the closest star to our solar system. It's only 4.2 light years away. That means a beam of light that starts from this star reaches Earth in 4.2 years. That's also 270,000 distances from Earth to the Sun. The star Proxima Centauri itself is too pale for us to see with the unaided eye in the night sky, but its system hides a little secret. Let's fly there and take a closer look. So here's this red dwarf. It's 7 times smaller than our Sun and 8 times lighter. Proxima Centauri is 1.5 times bigger than Jupiter and almost 150 times heavier. But what we're looking for is a little further away. If the signal from Proxima Centauri is also a message, we'll need time to decode it. So let's fire up our super-powered computing machine and wait for the result. But this isn't the first mystery signal we've ever picked up on Earth. Scientists recorded an unusual wow signal in 1977. They supposed it came from somewhere in the constellation of Sagittarius. The telescope was picking up the unknown signal for an impressive 72 seconds. Later, a scientist who looked at the printout of the signal concluded that the signal was artificial. He wrote, "Wow," on the printout as his reaction. The following observations and studies couldn't catch this signal again. Some theories said that this signal came from a celestial spaceship flying by. It had flown away, and we could no longer detect the signal. But most likely, this signal was created on Earth. It was directed upward but reflected off an object at a high altitude. It could have been an airplane, a satellite, or space debris orbiting our planet. Then the signal was picked up by the telescope, and because it was human-made, all of its characteristics, like wavelength and frequency, could have confused scientists. In 2017, scientists recorded a flare on Proxima Centauri. The star's brightness increased by 1,000 times in just 10 seconds. Before that, there was another flare there that was weaker but lasted about 2 minutes. With these flares, Proxima Centauri has emitted enormous amounts of radiation. Even if there was life on the star's companion planet, these flares would have likely destroyed it. The stellar winds would have simply blown the atmosphere off the planet and made its surface lifeless. Overall, the planet Proxima Centauri b receives 60 times more high-energy radiation and 400 times more X-ray radiation than Earth. Scientists have concluded that the probability of life here is 1 to 100 million. And while we don't know yet for sure if the signal was artificial or natural, the scenario of a bunch of spaceships coming to Earth is most likely possible. Our only method for searching for outer space civilizations is using radio waves. They're like loud noise that blasts away from our planet in different directions at the speed of light. The main problem here is the gigantic distances. Our galaxy, the Milky Way, is 100,000 light-years wide. Suppose there's life at the other end of it. If we send a radio signal to them, it won't reach that supposed planet for another 100,000 years. And we won't get a response for another 100,000 years. It's the same if someone once wanted to contact us. We didn't learn how to create and receive radio signals until the 19th century. If a civilization was developing at the same time as us somewhere in the Milky Way and they invented the radio, we won't get their signal for several millennia. Plus, the radio noise from our planet is starting to fade away. We use Bluetooth, fiber optics, cable TV. So in about 100 years, we'll no longer be visible to other worlds. Or worse, what if there was an outer space civilization somewhere that was sending signals into space? The signals were reaching our planet, but we didn't yet have the technology to pick them up. The world that was sending the signal has evolved, and the signal went out. We could have caught those remnants of the radio waves that were moving through the universe, but we set up the antennas too late. There are about 2 trillion galaxies in the universe. Each of them contains billions and trillions of stars similar to our sun. Maybe there's a planet near one of them that looks like ours. Life could be blooming there. And this outer space civilization, just like us, is looking through telescopes in hopes to catch the radio signal from an unknown planet. This may look like a scene from a cool sci-fi movie or an astonishing painting, but it's actually real-life footage of Mars, the very planet known for its bright rust color. Layers of rock and dust cover the planet's surface. They consist of iron-rich minerals. That's why dust on Mars is mostly iron oxide. It floats in the atmosphere and creates an orange-red haze around the planet. But Mars has some even more amazing things, like these blue speckles on its surface. They look like a wind-sculpted sea of dunes around 19 miles wide. Astronauts saw these dunes at the northern polar cap of the planet. That's a region that covers an area approximately as big as Texas. The blue dunes, formed by winds, are shaped like long weaving lines. The winds on Mars are relentless and strong. They turn the barren surface of the planet into terrains of grand beauty. These winds are influenced by many different factors. For example, temperature fluctuations to the way the planet's atmosphere circulates. The atmosphere is thin on Mars. That's the reason liquid water most likely can't exist there for any long period of time. That's why, even though Mars is only half the diameter of our planet, it has the same amount of dry land as Earth. A thin atmosphere is also the reason why wind needs to be exceptionally strong and fast to move the sand and form such shapes as these dunes. Winds usually move at 10 to 20 miles per hour on Mars. Anyway, even though the image looks pretty colorful, the dunes aren't actually blue. The bluish patches represent colder parts, while the warmer regions are yellowish-orange. The images were part of a set of photos released to celebrate the 20th anniversary of Odyssey, a spacecraft orbiting Mars. Mars has numerous sand dunes in different locations all over its surface. Some of them formed 1 billion years ago, like the ones in the Valles Marineris region. They haven't changed because both the atmospheric pressure and wind patterns there have remained the same. But some things do change. For example, some dunes get covered with frost. Here, the main dune has a series of dark patterns. It may be because frost comes and goes, depending on the season. Mars has 4 seasons, just like Earth, but they're twice as long as ours. It's because Mars needs around 2 Earth years to orbit the Sun. Seasons are harsher in the south of the planet than in the north. During southern winter, the planet is farthest away from the Sun. Mars moves pretty slowly, and its orbit is elliptical, different from the orbit of Earth, which is almost circular. Spring on Mars is a season with plenty of dust storms that start in one part of the planet and, eventually, turn into huge storms. They become so large, they blanket the entire planet. Each planet of our solar system has something that makes it special. Jupiter, for example, is not only the largest planet, more than twice as big as all other planets combined, but it also has the biggest ocean in the solar system. Jupiter is made of similar elements to the Sun. They're mostly helium and hydrogen. In the deeper parts of the planet's atmosphere, temperature and pressure increase. That's why the hydrogen gas gets compressed and turns into liquid. That gives Jupiter the biggest ocean, but it's made of hydrogen, not water. There's also a theory that somewhere halfway to Jupiter's center, the pressure increases so much that electrons start getting squeezed out of hydrogen atoms. This allows the liquid to conduct electricity as effectively as most metals do. Jupiter is rotating fast, which creates electrical currents and generates a strong magnetic field. But as a gas giant, the planet doesn't have a firm surface. The planet's swirls and stripes are cold, windy clouds of water and ammonia. Jupiter also has the iconic Great Red Spot, which is an insanely large storm with crimson-colored clouds spinning counterclockwise. Winds there are way faster than any hurricane on our planet. The Great Red Spot has slightly changed throughout time and is currently bigger than our planet. It's 1.3 times as wide as Earth. Scientists have discovered that its roots extend more than 200 miles into Jupiter's atmosphere. A regular tropical cyclone we see on our planet can only extend 9 miles from the top to the bottom of the storm. These days, the red spot is becoming smaller and taller at the same time. Jupiter also has dozens of moons and a couple of rings, but unlike Saturn's rings, these are quite faint and mostly made of dust, not ice. Also, there's a salty ocean under the surface of Jupiter's biggest moon, Ganymede. It's hidden below a thick icy crust. It's likely to contain more water than all surface water reservoirs we have on Earth combined. The theory says this ocean is around 60 miles deep, 10 times greater than the deepest point of our planet's oceans. Jupiter and Saturn contain 10 million tons of precious stones. The pressure inside these planets' atmospheres can actually turn carbon into small pieces of diamonds. If you put these diamonds under extreme temperatures and pressure, they can melt. This would probably result in some sort of diamond rain. In the beginning, our solar system was just a swirling cloud of gas and dust. It eventually developed into a spinning disk, with the central star in the middle. Almost all planets in our solar system move counterclockwise around the Sun. Venus is the only planet that rotates in a clockwise direction, and Uranus rotates on its side. These planets are most likely different because long ago, huge asteroids collided with them and kinda knocked them off their course. There's a chance Venus could be a habitable planet. It's definitely not a place you'd want to live now, not with its sulfuric acid clouds and tremendous atmospheric pressure. It's 90 times greater than that on Earth. Add here insanely high temperatures. The conditions on Venus are very unfavorable for people. At 863 degrees Fahrenheit, Venus is hotter than Mercury, even though it's further away from the Sun. This happens because there's too much carbon dioxide in Venus's atmosphere. It traps heat, which causes the temperature to rise way higher than it's supposed to. But simulations showed that around 700 million years ago, Venus might have been a nice place with moderate temperatures and liquid water. Those conditions were slightly similar to those we have on Earth now. Uranus is not a gas giant. It's actually made of ice. The atmosphere contains methane, which makes the planet look blue. It has 27 moons, 2 sets of rings, and lots of ice in its atmosphere.
Hey, listen up. Do you want to lose weight fast or gain more mass in just a few seconds? Forget all about diets and sports. We have an out-of-this-world way to do it: space travel. And now I'm taking you to the heart of our solar system, to the Sun. Hold on and bring your shades. There's no solid surface here, just hot liquid plasma. So take your heat-reflective suit and stay on the platform just above the boiling surface of the star. On Earth, you weigh 135 pounds, but here on the Sun, your weight is about 3,600 pounds. That's like a small sedan or a hippo. Hey, just saying. It has to do with gravity. The bigger and denser a space object is, the stronger its gravitational pull, and the heavier your body feels. The Sun is 99% of the mass of the entire solar system, but although the star is 333,000 times as heavy as Earth, it's also much bigger. That's why gravity is only 27 times stronger on its surface. You can't stand up straight here, you get pulled down by gravity. And if on Earth you could lift 135 pounds of your own weight, here you can only lift a small pumpkin. Happy Halloween! Moving on, Mercury, the closest planet to the Sun, is very hot, about twice as hot as the maximum temperature in your kitchen oven. You jump down onto the rocky surface of Mercury and step on the scales. They show only 51 pounds compared to your real weight of 135 pounds. Mercury is almost 17 times smaller than Earth, but its core and crust are very dense. So the gravity here is only 2.5 times weaker than that on our home planet. It means you can jump 2.5 times higher here, and you feel much stronger. You can lift a big gorilla, but don't forget to make it wear a spacesuit with an oxygen supply. When night falls on Mercury, the planet cools down incredibly quickly. The temperature drops to 3 times as low as at the North Pole. So let's get out of here before you freeze completely stiff. The next planet is Venus. Oh, there's a nasty smell. It's the sulfur dioxide in the air. It would also smell like this near a volcano on Earth. You get on the scales and 122 pounds, almost as much as on Earth. No wonder Venus and Earth are called twin sisters. This planet has almost the same size as ours and only 20% lighter, so it has almost the same gravity. But you couldn't live here because Venus is the hottest planet in our solar system, and the atmospheric pressure on its surface is 92 times as high as what we have on Earth. You'd only feel the same pressure if you dive 3,000 feet underwater on our home planet. Without special equipment, you'd be crushed at such a depth. Your spacesuit is made of titanium to withstand this kind of pressure, just like an atmospheric suit for deep-sea diving, and it weighs about 830 pounds. It's like carrying the weight of a motorcycle. That's why you feel weaker here than you do on Earth. But moving on to our home planet, or more specifically to its satellite, the Moon. Several astronauts have been here before. You might have seen videos of how awkwardly they moved around, sometimes even fallen. That's because gravity on the Moon is 6 times weaker than on Earth. Your solid 135 pounds of weight turns into 22. So now, you weigh like a plastic shopping cart. On the bright side, you can now lift 6 times that weight. You can flip a car or lift a pony. You can probably even lift the lunar rover that's still standing here left by the last moon mission. One of the astronauts, Alan Shepard, hit several golf balls here, and one ball weighs less than a half an ounce on the moon. Hey, maybe you can use all that power to clean up the stuff people left here. That's about 250 tons, including rovers, broken space probes, lunar module sections, golf balls, and the like. Nah, let's do the cleanup later. Now we're going to Mars. Hey, you're the first human on the surface of the red planet. And the first thing you do is weigh yourself, of course. 50 pounds, almost 3 times less than on Earth. It's even less than the weight of a capybara, a big rodent from South America. That's because Mars is 50% as light and 10 times as small as our home planet. And since gravity is weaker here, you become 3 times stronger. You can lift 2 of your friends. But this kind of gravity is actually a problem for people. We're planning to colonize Mars, but our muscles are used to the constant gravity of Earth. They won't work at their full capacity on the red planet. This will cause health problems for the astronauts, so they'll need to exercise all the time or tie weights on themselves to become heavier. They'll have to carry at least 10, 20-pound dumbbells to get close to their real weight and keep their muscles toned. Now, a quick trip to Jupiter. This is a gas giant, hey, again with a gas, and it doesn't have a solid surface. All you see are dense clouds, so it's probably best to stay on the platform. Jupiter is 317 times as heavy as Earth, so the gravity here is much stronger. Your scales show 340 pounds. That's like the weight of a big wild boar on Earth. Now, you can barely stand on your feet in your spacesuit. You feel very weak. The maximum weight you can lift here is 60 pounds. That's as much as a husky dog weighs. Let's take a look at Jupiter's moon, Europa. You stand on the scales and see 18. Yup, gravity is so weak here that you weigh like a garden gnome. At the same time, you can easily lift 1,000 pounds. That's like a horse or a grand piano. With that kind of strength on Earth, you could flip a school bus or lift a small car over your head, if you wanted to. Moving on, Saturn, another gas giant. Hold on tight, woohoo, winds here can reach 1,100 miles per hour. Such a gust of wind could carry you across the United States from one coast to another in just 2 hours. Hurry up and get on the scales, 144 pounds. It's a little more than you weigh on Earth. That's why you feel a little weaker, like after a good workout at the gym. Saturn's moon, Titan. You might want to stick around a bit longer because here you feel like a real weightlifter. You can lift 7 grown-ups in your arms, or a great white shark. Just be careful with those teeth. And your own weight here is about 17 pounds, like a domestic cat, maybe a fat tabby. Uranus is the coldest planet in our solar system. It's 10 times as cold there as in a freezer. The scales show 120 pounds. You can lift a truck wheel here. The last planet in our solar system, Neptune. It's 17 times as heavy as Earth and 4 times its size. And the strongest winds ever recorded blow here. The number on the scales is 150 pounds. Yep, you've gained a little weight. But the same would happen if you took a dumbbell in your hands on Earth.
It was the year 2017 when astronomers spotted a bright star hurtling out of the Milky Way. It was moving incredibly fast at a speed of 2 million miles per hour. That's almost 4 times as fast as the Sun orbits around the center of our home Milky Way galaxy. It takes our star more than 225 million years to complete one journey. Anyway, back to our star, the Wanderer. The main issue with it was that it was moving against the direction in which most stars travel around the center of our galaxy. Even more bizarre, it consisted of totally different star stuff. Astronomers managed to identify its composition. The star was made up of heavy metallic atoms. At the same time, most of the other stars consist of way lighter elements. The wandering star got the name LP 40-365. It was moving so fast that it literally dashed out of our galaxy. This made scientists believe that the space traveler was pushed out of its place by some kind of cosmic disaster, like a supernova. A supernova is the largest explosion that can take place in space, an explosion of a star. It happens after irreversible changes start in the core of a star. Supernovas can occur in 2 ways, in binary star systems and when there's a single star. Binary stars are 2 stars orbiting around the same center. At some moment, one of the stars, a very dense white dwarf, starts stealing matter from its companion. After some time, this thief accumulates too much matter, which causes it to explode into a supernova. Or it can be a single star nearing the end of its life. It's running out of its fuel. More and more mass is flowing into the core of the star. In the end, the core becomes so heavy that it fails to withstand its own gravity. After the core collapses, a tremendous amount of energy is released in a supernova. But astronomers still can't figure out how a supernova could send LP-40 flying. There are more questions than answers. Was it a companion star that got flung out by a shockwave created by a supernova? Or was it a piece of the exploded star? A new study based on the collected data has shown that the star, which is a white dwarf, keeps slowly rotating around its axis. Astronomers are almost sure it means LP-40 is indeed just a chunk of space debris, and not a full-fledged star. This wandering piece somehow managed to survive one of the fiercest space events. But after making such a conclusion, scientists realize something amazing. LP-40's unusual features could appear after the star witnessed a supernova. Even though this event happened lightning fast, the entire makeup of the star got changed. Most stars consist mainly of helium and hydrogen, but LP-40 is different. It contains such heavy elements as magnesium, oxygen, and neon. It must have been the supernova that added these atoms to the star's composition. By the way, astronomers consider all elements that are heavier than helium to be metals. This means that after witnessing the supernova, LP-40 became metallic. Right now, the star doesn't have its own planets, but NASA's Transiting Exoplanet Survey satellite, which is on the lookout for distant planets passing in front of their host stars and dimming them, has noticed a curious thing. LP-40 bright